If Antarctica's ice cap were to melt, what would happen? To put it simply, it wouldn't be a good thing. Let's find out why. Indeed, climate change is a well-established phenomenon. Undoubtedly, it is evident that the human population has been significantly contributing to the release of substantial quantities of carbon dioxide into the Earth's atmosphere, thus leading to a discernible alteration in the global climate. The current situation appears to be quite unfavorable. The situation may be extremely unsettling. What would be the potential consequences of a significant rise in global temperature leading to the complete melting of the Antarctic ice cap? What is the current volume of water on Earth? And what would be the corresponding increase in sea level? What is the status of the Arctic polar cap? Why is there a lack of debate on the negative consequences resulting from the melting ice at the North Pole? And this is alarming due to the increasing rate of ice melting throughout the summer season. Let us begin the topic at hand with the ice located at the South Pole. In order to obtain a preliminary approximation of the magnitude of Antarctica, one may conceptualize it as a circular entity possessing a diameter equivalent to the width of the United States. Indeed, a connection has been established between a subject matter that you may not possess a strong emotional connection for and a concept that you may have prior knowledge or experience with. However, it is important to note that there is more to consider. Estimating the average depth of the ice sheet at the South Pole presents an additional challenge. Based on the data, the mean ice thickness measures 1.9 kilometers. The quantity of ice is really enormous. The ice sheet can now be conceptualized as a substantial cylindrical structure resembling a hockey puck in its shape. The volume can be determined by multiplying the area of the base, which is in the shape of a circle, by the height. For the sake of convenience and simplicity in future calculations, it is preferable to maintain the measurements in units of meters. However, it is important to note that the increase in ice volume does not necessarily correspond directly to an equivalent increase in sea level. The density of ice, which is 920 kilograms per cubic meter, is lower than that of liquid water, which is 1,000 kilograms per cubic meter. This anomaly can be attributed to the peculiar behavior of H2O, as its density reduces upon freezing. The preservation of mass is a fundamental principle that remains invariant during the process of ice melting. The resulting volume of water obtained from the melting ice is approximately 3.14 times 10 to the 16th cubic meters, which is significantly smaller. Now, let us proceed with looking at the negative aspect. The proposal is to distribute the surplus water uniformly across the entirety of the Earth's surface. In fact, the phenomenon occurs primarily above the Earth's oceans. But what's the surface area of Earth's oceans? Assuming Earth is a spheroid, it possesses a radius of around 6.37 million meters, although it should be noted that its equatorial circumference is slightly greater than its polar circumference. The surface area of the sphere can now be determined. Approximately 70% of the whole surface area is comprised of water, a fact that is remarkable upon thinking. Consider the hypothetical scenario in which the solid state of water, commonly referred to as ice, undergoes a phase transition and transforms into its liquid form, known as water. This liquid water is then evenly distributed across the vast expanse of the Earth's seas. In the hypothetical scenario where the ocean were to possess a geometric shape characterized by equal sides, resembling a perfect square, the resulting melted water would adopt a rectangular form, exhibiting a flat surface and possessing an area equivalent to that of the ocean. Furthermore, the depth of this rectangular body of water would correspond to the magnitude of the rise in sea level. In order to determine the increase in water level, it is necessary to calculate the quotient obtained by dividing the volume of melted water by the surface area of the ocean. Based on the available data, it can be determined that the projected increase in sea level would amount to 88.619 meters or 290.745 feet. The severity of this situation is clearly visible. Despite potential inaccuracies in our projections, it is evident that a substantial increase in sea levels is quite probable. That would be highly undesirable. It should be noted that this is merely an approximation. The consideration of the loss of land surface area resulting from the inundation caused by the gradual rise in sea levels was not factored into our analysis. This phenomenon would effectively mitigate the rate of sea level rise, as it would allow for a larger expanse over which the water may disperse. It is important to note that in our analysis, we neglected to account for the Earth's curvature, and instead assumed a planar surface, a perspective that aligns with the beliefs of flat earthers. However, given the relatively small magnitude of the sea level shift in relation to the Earth's radius, we claim that this approximation is reasonably acceptable. While it may be acceptable as an approximation, it should be noted that the potential consequences of this scenario would be highly devastating. However, it is important to consider the situation of melting ice in the North Pole. While there is a notable amount of melting occurring, its impact on the rising of sea levels is negligible. A notable distinction lies in the fact that Arctic ice is predominantly located in a floating state, whereas Antarctic ice primarily rests upon land masses. What is the significance of this matter? Consider a hypothetical scenario where a container of water is presented containing a solitary ice crystal of considerable size. The buoyancy of ice is attributed to its lower density compared to that of liquid water. Now, consider the hypothetical scenario of substituting the previously mentioned water block with a metal block that possesses identical dimensions. Water is still present in the vicinity of the metal block. The force exerted on the object should be consistent with the manner in which it initially interacted with the water block. This implies that the upward buoyancy force remains constant and is equivalent to the weight of the water block, rather than the metal block. In the scenario involving the metal block, the buoyancy force, although there, would not suffice to maintain its flotation, resulting in its submersion. When ice is present in water, it causes the displacement of a certain volume of liquid water. However, due to its buoyancy, the floating ice will cause the displacement of a quantity of water that is equivalent in mass to the ice itself. Consider the hypothetical scenario in which the ice undergoes a process of melting. Despite the alteration in volume during the phase transition of ice from solid to liquid, the mass remains constant. The resulting water from the melted ice now occupies an equivalent volume to that which was previously displaced by the ice cube. There is no change that can be seen. Let us now switch our focus to the phenomenon of ice melting within a container of water. The overall water level within the glass will remain constant during the process of ice block melting, on the assumption of negligible evaporation. This is the reason why concerns regarding the Arctic ice are irrelevant. One must express concern as it serves as an indication of climate change, albeit not specifically pertaining to the phenomenon of sea level rise. In addition to the anticipated sea level rise, it is crucial to consider additional consequences that may arise from the complete melting of the Antarctic ice. The force of gravity would undergo a significant shift. The impact of Antarctica's ice melting on sea level rise is evident. However, the mechanism involved in this process is more complex than a mere addition of the volume of newly melted water to the oceans. According to data scientists, additional implications would also manifest in the downstream context. Firstly, it is quite probable that the melting of ice will lead to a gravitational shift. The modification will result in the expansion and elevation of certain land regions. This approach will help alleviate the effects of sea level rise. Nonetheless, it is important to acknowledge that it may give rise to additional noteworthy ramifications. The comprehensive understanding of the complicated impacts on global sea levels and regional land movement remains a complex and incompletely elucidated subject. Nevertheless, researchers express apprehension regarding the profound transformation. The potential consequences of such an event would be an abrupt and alarming disruption to the challenging equilibrium of Earth's ecology. Scientists have devoted several decades to the investigation of this phenomenon. In the year 1875, James Crowell, a researcher, put up the argument that the melting of the ice in Antarctica would lead to a non-uniform increase in sea levels. The phenomenon is currently recognized by scientists as the gravity effect. Crowell's research indicated that the increase in sea levels near Antarctica will be significantly lower compared to the global average. On the other hand, it is anticipated that the Northern Hemisphere would encounter a sea level increase that surpasses the average by around 1/3. The understanding of the geographical impact of melting ice on sea levels has been further enhanced via subsequent computations conducted by other mathematicians. However, the basic idea remains unchanged. The process of glacier melting induces a gravitational shift, resulting in differential impacts on sea levels throughout different regions of the globe. As an illustration, the melting of ice in Greenland would result in decreased sea levels in close proximity to the land mass, while causing elevated levels in more southerly regions. The presence of these inequitable distributions would provide significant challenges in effectively relocating large populations to inland areas as a means of mitigating the impacts of rising sea levels, hence intensifying the problem at hand. The axial movement of the Earth would potentially result in a catastrophic shift. The rotation of the Earth's axis is not a smooth process. Likewise, the Earth exhibits a small wobbling motion as a result of the uneven distribution of mass across its surface. From 1899 to 2018, the Earth experienced a displacement of approximately 34 feet, 10.4 meters, in its axis as a result of a combination of environmental and human-caused factors. However, the process of ice melting already constitutes a substantial component of the problem at hand. Indeed, it has been postulated by experts that over 50% of this transition might be attributed to the process of ice melting. The glacier melt has resulted in changes to the force of gravity. Land masses have undergone periods of expansion and contraction. The cumulative effect of these alterations has impacted the rotation of the Earth. The complete comprehension of this process has not been achieved at present. However, it is evident that the process of ice melting exerts a substantial influence on the Earth's axis. Subsequent modifications would consequently be seen with heightened intensity. The axial tilt of the Earth and the process of ice melting are two phenomena that have been extensively investigated over an extended period of time. However, the degree of their interconnection remains incompletely comprehended. The contribution of ice melting to the movement of Earth's axis is accompanied by other factors, including the movement of Earth's mantle, which also has an influence. Nevertheless, the complete melting of all ice in Antarctica is not required for the occurrence of substantial repercussions. As per the findings of paleoclimatologists, the process of glacier melting has the potential to initiate a feedback loop, so inducing subsequent changes in the climate system. The axial rotation of the Earth results in the exposure of the polar regions to dynamic warm water currents, hence potentially intensifying the process of ice melting. Once the process of ice melt commences, it becomes considerably more challenging to impede or reverse. This process can exert substantial effects on the Earth's climate system and the levels of the Earth's oceans. Indeed, the global community is currently witnessing certain manifestations of the aforementioned phenomenon. However, experts express significant concern regarding the anticipated worse of the situation due to the acceleration of the melt rate. Longer or shorter days. The potential complete melting of the ice in Antarctica would give rise to complex and interrelated consequences for Earth's systems, rendering the task of accurately forecasting the precise outcomes challenging. Nevertheless, it is established among researchers that this occurrence has an impact on the duration of a day. The rotational behavior of the Earth has experienced noticeable changes resulting from the melting of glaciers and the subsequent introduction of meltwater into the Earth's oceans, as observed and quantified using satellite-based and astronomical measurement techniques. The phenomenon of polar wander is influenced by various reasons, one of which being climate change. According to Jerry Mitrovica, a geophysicist from Harvard University, the melting of glaciers at high latitudes results in the redistribution of water from these regions towards lower latitudes. Similar to the actions of a figure skater extending their arms outside from their body, this phenomenon serves to decelerate the rotational velocity of the Earth. As a result, the process of ice melting and the subsequent redistribution of its water around the planet leads to discernible alterations in Earth's rotational speed. Similar to the case of Mitrovica, the phenomenon can be likened to that of a figure skater who modulates their weight and rotational velocity by manipulating the position of their arms during a spin on the ice. The ongoing process of ice melting, which has been occurring for several decades, has resulted in a marginal increase in the duration of a day by a fraction of a second. The extent to which the duration of a day would be extended by the complete melting of Antarctica's ice is uncertain, but it has the potential to be quite substantial. Recent estimates indicate that there is a possibility of a day experiencing a time deviation of up to 20 seconds in the forthcoming years, and maybe even more substantial deviations in subsequent periods. It is anticipated that there would be a significant loss of coastal cities on a large scale. Antarctica and Greenland are known for their significant ice reserves. The potential melting of glaciers and ice caps would entail major implications for the sustenance of life on our planet. According to a report by National Geographic, in the event of a cessation in the rise of sea levels, numerous coastal cities such as New York, New Orleans, Buenos Aires, Cairo, London, Venice, Shanghai, and Bangladesh would face complete submergence. Likewise, significant land masses would also have severe impacts. The potential consequences of such an event would have significant adverse effects on both the human population and the surrounding ecosystems that rely on these particular regions. The displacement of millions of individuals from their native homelands and long-standing communities would occur. As a result, a multitude of individuals would experience subsequent health, economic, and geopolitical difficulties associated with the relocation from their own territories. In the event of a complete melting of all ice on Earth, it is estimated that a significant proportion, specifically around 80% of the Australian population, resides in regions that would promptly become submerged. Also, this would have implications for a region in China that is presently inhabited by approximately 600 million individuals. It is projected that Denmark and the Netherlands would experience a significant rise in sea levels, resulting in a substantial portion of their land being flooded. Moreover, a significant portion of the eastern coast of the United States, encompassing regions such as Florida and the Mississippi Delta, would face the prospect of submergence. A significant portion of Paraguay and a substantial area of Central America become submerged. Certain major cities, such as San Francisco and Phnom Penh, would undergo a transformation wherein they would be surrounded by water, thereby becoming islands. Although Africa may encounter a relatively lower degree of land loss, the subsequent increase in temperatures would render a significant portion of the continent uninhabitable. According to scientific estimates, around 40% of the global population resides in regions that will be impacted by the aforementioned scenario. Undoubtedly, a substantial increase in sea levels would have catastrophic implications for the human population. The reintroduction of long-preserved microorganisms into the environment is inevitable. The melting of ice in Antarctica will not only contribute a significant volume of water to the Earth's system. That would be sufficiently damaging. Likewise, this endeavor will reveal species that have been preserved in a frozen state beneath the ice for millions of years. A study conducted by Chilean researchers in 2011 focused on the examination of microorganisms inhabiting the Antarctic ice, leading to the discovery of surprising results. The researchers discovered that these microorganisms exhibited a remarkable ability to endure exceedingly low temperatures. The microorganisms exhibited the capacity to endure in habitats characterized by elevated levels of salinity, excessive levels of acidity and alkalinity, and temperatures reaching up to 200 degrees Fahrenheit, 93.3 degrees Celsius. One microorganism was discovered to possess the ability to endure radiation levels that surpass those encountered by any other known life on Earth by a factor of 5,000. Despite being discovered at a depth of 50 feet, 15 meters, below the ice surface, these organisms exhibit remarkable resilience and possess the potential to be quite hazardous. A lack of consensus exists among researchers regarding the role of specific microorganisms. Currently, all theories remain under consideration without any being definitively excluded. However, the finds have been the subject of considerable scholarly discourse. Moreover, supplementary samples collected from several bodies of water appear to have corroborated the initial findings of the Chilean researchers. The lake, situated beneath a substantial layer of ice in the western region of Antarctica, has yielded samples that exhibit distinct characteristics not observed anywhere on our planet. The distinctiveness of these entities was such that they were employed as substantiation for the plausibility of life's existence in exceedingly harsh extraterrestrial environments. However, the implications of this phenomenon remain unclear to the scientific community. The potential repercussions of releasing these bacteria remain uncertain. Individuals with a heightened sense of concern contemplate the potential for a catastrophic event that may result in widespread illness and the cessation of familiar existence. The course of ocean currents is anticipated to undergo changes. Thermohaline circulation refers to an extensive system of deep ocean currents that span the entire globe. It is sustained by variations in temperature and salinity of the seawater. Based on the findings of the National Oceanic and Atmospheric Administration, NOAA, it is the wind that serves as the primary driving force behind surface ocean currents. The poles and the existence of ice are significant factors in the formation of deep water currents. This phenomenon occurs when the process of freezing water results in the formation of sea ice, thereby leading to an elevation in the salinity levels of the surrounding water. The water with a higher density and salinity exhibits a tendency to sink. After that, it is substituted by water with lower salinity originating from the surface. The aforementioned phenomenon persists in a cyclic pattern, commonly referred to as the global conveyor belt. This action results in a modification of the global circulation patterns of oceanic water. Consequently, it modifies the migratory patterns, living conditions, and survival strategies of schools of fish, shark populations, and other marine organisms. Antarctica has a crucial role in the regulation of temperature and salinity throughout the southern oceans. The process of sea ice melting would have a profound and irreversible impact on the characteristics and dynamics of the oceans. The potential disappearance of the Antarctic ice sheet may give rise to adverse repercussions. The ecosystem of Antarctica exerts significant influence on the movement of salt in the region, hence prompting adaptive responses among animal species inhabiting the southern hemisphere. The changing of currents would potentially reverse millions of years of evolutionary progress. The depletion and migration of fishing stocks pose a significant threat to the world food supply, potentially endangering mankind's access to a crucial source of sustenance. Changes in the concentration of salt water and the distribution of fresh water would have a profound impact on the existence of several aquatic species. As Emmanuel Macron, President of France, says, by polluting the oceans, not mitigating CO2 emissions, and destroying our biodiversity, we are killing our planet. Let us face it, there is no planet B. You can suggest topics you want to see next in the comment section below. Please subscribe to Weather Collapse if you want to know more, and be updated on the latest news about natural calamities or disasters happening all over the world, and don't forget to like today's video. We'll see you in the next video. Thanks for watching.